Hello and welcome to this webinar on 5 steps to navigate the WHO temperature mapping guidelines. We'll just give the last people a few minutes to log on, and we'll see you in a short bit. Hello and welcome back. I see we have a lot of people joining in. So if you feel comfortable, please write in the chat where you're listening from. We have a lot of people from
all over the world.
All over the world. Yeah. There's definitely a lot of different places popping up here. That's really nice, and I hope you're all doing well. It's becoming summer in Denmark.
So, slowly.
Finally,
a bit of sun here.
Yeah. And hello, Alessandro. It seems like
buongiorno, Alessandro. See.
Great to have some friends, some acquaintances drop in here as well. We'll be starting in just a short while here. We'll just have the last people joining in. It will definitely be a very interesting talk today, discussing WHO temperature mapping guidelines. Hot topic, yeah.
No pun intended.
No pun intended. Yeah, welcome everyone. It's good to see so many people. Yeah. So I'll just switch over here.
Yes.
Like this, sorry. So
perfect.
Today's topic, temperature mapping guidelines, and with the focus on WHO.
Exactly. We'll try to narrow down into 5 main steps to help you navigate those WHO temperature mapping guidelines. And just a brief introduction of who are we, right? My name is Aleš, and I'm working as a BDR manager and quality consultant for UPRI. Been part here like now it's almost 4 years. Times fly when you have fun.
Yeah.
And I have a different background from quality control to hospitality management, and now I'm back into my older roots with a more commercial aspect on top of that. But I do really love those kind of topics, so I'm actually very privileged joining Jakob in this webinar.
Thank you very much,
our
Alex.
Experts.
So my name is Jacob, and I'm a co-founder here at UPRI, and I'm the head of quality as well. I've been with the company since the beginning, so this is on Friday, I believe it's 10 years.
Exactly.
So I'm dealing a lot with temperature compliance as a whole, both in terms of temperature mapping, temperature monitoring, calibrations, and so forth. My background is in electrical engineering, so I'm very privileged to have sort of the more technical background for all of this. We're very excited. But let's just go over what we're going to talk about today.
Yes.
Because we'll be covering a lot of different topics, that's for sure.
Yeah. So, briefly, the agenda for today, we'll start kind of obviously with the mapping process in general, just to have a quick overview so that we are all on the same page what mapping is. Then we'll dive into why WHO is kind of one of the most broadly used standards across the globe. We'll go a bit deeper into the importance of temperature mapping and the overview of the WHO guidelines in regards, and how to kind of help us navigate and understand them. We'll also kind of see how is the alignment with WHO with other guidelines and see where they kind of merge together. How is this harmonization done across different kind of entities in this realm. And we'll end up with kind of give you our 5 best tips on how to navigate those guidelines.
Absolutely. And I mean, we could talk for hours on different guidelines on mappings and how to do this, but today will be a good overview of why WHO guidelines matter and sort of the key points in there. And thank you very much, Mike, for stating your purpose of here. Actually, if you feel like it, please feel free to ask questions during this webinar, and we'll do our best to answer them along the way. We also have a Q&A at the end. But we love to have these webinars where we can interact with all of you. So if there's anything along the way, don't hold back in terms of
it is always more fun when it's a bit more dynamic, right? It's it is not that robotic here.
Absolutely. So
okay, let's move further. So who are we as well, right? Besides like us as individual, but who UPRI is, right? So we are a Danish company that has been founded about 10 years ago. We have, as Jacob mentioned, our anniversary this Friday. But basically, what UPRI created is a one-stop solution to guarantee temperature compliance in, GMP environments, GDP environments, life science in general, in all sorts of different industries. So what we kind of do here is creating basically an umbrella that covers all the main topics and to stay compliant within temperature. So that means that we develop hardware, we develop software, but this is just a tiny part of what means to be compliant, like having the right hardware. Then it's the whole software part, is the whole quality process behind the mappings that we can perform. So it's really an umbrella that covers everything, but also the service itself has to be up to certain standards if you want to work in this environment. Absolutely. Right? So
I like to think often of is that we're trying to sort of be a secondary quality department in terms of the full life cycle of temperature compliance. So we always strive to take every aspect of temperature compliance and help our customers solve some of those tasks that are inevitably part of temperature compliance. And that also includes mapping.
Exactly.
As we're going to talk about today.
Mapping, calibrations as well, right? And of course, we have a whole set of amazing quality engineers that are kind of able to assist you with, from writing SOPs to protocols to assist you also during the mapping processes, etc.
Absolutely. So should we get started?
Yes, let's go.
The good stuff here. So starting with the mapping process, just to get everyone on the same page, we have a lot of different webinars, and I urge you all to go and look at them if you're interested in temperature mappings. But just to get on the same page in terms of what the mapping process is, we have a few slides on that. First of all, it's important to understand that temperature mapping is not a standalone practice that you need to perform. It's part of a process validation approach, which basically you should already know if you're working in the GXP industries, with everything from specifications onto acquisition or building or configuring phase up until the testing phase. And this is really where the mapping comes in, right?
Exactly. Basically, if you want to say kind of in a really simple terms, it's an exercise to verify that the equipment is fit for purpose.
Exactly. And that's really, that's a good phrase, because that's really what we're seeing a lot of companies struggle with, understanding the basics of this. And if we are now, we're focusing on WHO guidelines today, they don't emphasize that, in my opinion, enough, at least, that mapping is really a part of a validation approach. It should not stand alone, but it's a very crucial part.
Exactly.
So just taking a step further, what are we going to talk about today? What are the different steps in the mapping process that WHO outlines? First of all is the protocol. So you need to define a protocol, and we'll get much more into details on some of the important topics within that defines what is your methodology, which kind of documentation would you expect to achieve after a mapping exercise, and pretty much lays out your risk assessment. So how did you perform risk assessments? Where did you choose to place data loggers? That's one of the questions we get every single time. How many data loggers should we place? But that should all be stated in the protocol together with the scope and the expected outcome and the acceptance levels. So those are some of the things we'll take a look at today as well. Then there's the execution, so actually performing the mapping exercises, setting up data loggers, measuring data, opening doors, power failures, all these different things which can be part of a mapping exercise. And then the reporting part. So at the end, reporting, what were your actual results? Did they live up to the requirements and the acceptance levels that you stated out in the protocol? And if not, why not? And is it still acceptable? Yeah. So all of these things tie together in a mapping exercise, one could say, or mapping activities. While some of it is physical out there measuring, the protocol and the reporting is a really, really key part of having a compliant mapping strategy.
Basically, protocols are your roadmap for the whole exercise, right? How you should execute and what is kind of the desirable outcome and all that. And then the reporting is kind of the actual analysis of the whole exercise.
Exactly.
So you go through the whole ton of data and kind of try to understand what are your critical areas and if they actually match with your previously stated risk assessment, correct?
Absolutely, yeah. Absolutely. Yeah. So moving on here a bit.
So why actually mapping is important in the pharma industry, right? First of all, is critical for the critical touch points in the basically in the cold chain that we have in the life science industry, right? So that means that you are certifying fit for purpose different units in different stages of the cold chain. That can be from manufacturing units to storage facilities, vehicles as well, cooling appliances like fridges, freezers, and ULT freezers, right? So that's one point, right? But then it's also kind of guarantees mainly the product is the product's efficiency, right? That actually that the product itself comes to the end user or to the market fit for use, so that there were not fluctuations that had impacted the effectiveness of the goods that you've been actually handling. So the impact of fluctuations is actually something really underestimated throughout the cold chain, right? It's each year is kind of, there are billions lost in just kind of goods that have not been handled accordingly to standards. And what we have to understand here, it's also kind of that all of that, it's always product driven. So each product, so each kind of good, they have some different storage requirements. So that's another really important thing that we have to understand, because it's kind of not one size fits all in this case. It's very much depends this unit, what is storing.
Yeah, absolutely. I think you're absolutely right on that product understanding and product knowledge is really a key part in being compliant in terms of understanding what are and that's also one of the topics we'll really deep down today, is really what kind of products, how are they packaged and so forth, will have an implication of your requirements.
Exactly.
And that's really one of the, if you want to stand out to an auditor, that's really a place to show that you have knowledge of your process and you understand what the requirements for your process is. And then, of course, during the mapping exercise.
Yeah. I mean, that's a fundamental point to be kind of compliant with GMP or various GXP standards, right? And without executing kind of regular mapping exercises, you'll not be able to be within the same environment, right? But also, at the end of the day, it's also costs and financial implication in doing that, right? Because let's say I'm not, first of all, I can mitigate the goods loss in this case with the proper storage. That means that I can lower the insurances cost, most likely. On top of that is also your brand reputation at stake here, because if you are adhering to the highest standards of compliance and storage, that will add an invaluable credibility to your brand and to your company.
Absolutely. Yeah.
So why
why the WHO? I should ask you.
exactly
Why?
why so I do think it is because it's, first of all, has been established in 1950s, something like that, if I don't recall wrong. But it is kind of one of those regulatory bodies that is vastly recognized worldwide.
Yeah.
I think it has almost 200 member states in it. So, and it's a really respected authority, especially in setting health-related standards in this case.
Yeah, and it's also accepted by auditors from governmental and customer audits. It's really one of those standards that form the basis of a lot of the other standards that we'll also briefly mention today. But definitely it's recognized, and you shouldn't be afraid to, if you adhere to the WHO guidelines, you should be out of the bushes in terms of being compliant. Yeah.
But that's why also that, right? Because actually all the kind of guidelines that are actually stated in WHO have been written by experts. So it's actually there are basically inputs from top professionals in different fields that actually gathered together, and it's also that it's constantly kind of reviewed with different annexes or issues and all that. So it's actually something that is always evolving, and it's kind of partaking. It's kind of involving actually you guys in this case, right? So it's written by you.
Absolutely. And then, I think we should also mention that the WHO guidelines are free. That also gives a large viewership and reading of those guidelines. Contrary to ISPE guidelines, for example, which cost something, it's actually very cheap to get started on temperature mapping because you can go in and download it.
Exactly, and then we'll dive also later. But all those kind of guidelines, like also the ISP and WHO, they're really complementary to each other to some extent. So WHO standards or guidelines are the golden rule to start to be kind of compliant.
Absolutely, yeah.
And I think that's why WHO is recognized and is the most used guideline for that.
So a brief overview of the WHO guidelines that are relevant for temperature mappings.
So so the main components, of course, they are the same for any kind of mapping, right? Kind of has to be a seasonal exercise. So that means that you need to conduct the exercise both in the hottest and coldest month of the year. Like that, you kind of ensure that all kind of fluctuations are monitored and kind of monitored correctly, and that you have the proper risk assessment plan in place for both both seasons. So if you are kind of laid out a proper risk assessment plan for winter and for summer, then you're definitely covered also for spring and autumn, right?
Yeah, and I think if you're used to normal process validation and or CSV, you're used to the concept of worst case analysis or kind of trying to affect the equipment or the process in the worst cases. And this is also one of the questions we get a lot. Do we have to perform summer and winter? And WHO is actually quite clear on this topic in the sense that they state it as summer and winter. That's not actually what they mean. They mean worst case scenarios, but that happens to be summer and winter often for warehouses. But you can imagine other scenarios in which the worst case is actually not summer or winter, but is some other influence that I can't come up with a solution right now, or a suggestion. But yeah.
And far as I heard from also our customers, like the main issue in the winter are not, as you might think, the cold spots, are the hot spots from the HVAC system that are actually keeping the temperature. So you might have to conduct a study where you kind of reconsider the direction of your ventilation, because it perhaps will heat up too much a single spot and damage the goods that are actually stored in that area.
Absolutely.
So that's why usually summer and winter are the two main critical seasons to perform this exercise, and you should be more than okay. Of course, the WHO guidelines give you a blueprint of how to execute the documentation, what should be the content of it, but also kind of guidelines on the calibration that you have to use, and also mention the whole staff training. So first of all, regarding documentation, it is important that you have a detailed record of your activities, right? So, but this is also starts even before when you write your own protocols. So means kind of course, stating the purpose of the exercise. You need to state obviously also what will be the end goal and what you want to achieve with this exercise, and you have to include calibration data, temperature logs, if also having in place kind of how to handle non-conformities or deviations and action that will be taken. So that means in the guidelines you have a whole set of points that if you follow them, then you have for sure a good solid base to have an effective and efficient temperature mapping exercise.
Absolutely. I mean, if you follow the WHO guidelines, you will definitely have a good base. But of course, it's also important for us to communicate that it doesn't stand alone. Good documentation practice and good documentation practice SOPs within a company needs to be followed. That's one of the things we see along the way. Sometimes people rely too much on the WHO guidelines because they're not comprehensive in terms of Alcoa Plus principles. For example, they give a good baseline, but you should be cautious as to, first of all, which DXP industry you're in, and the definitive requirements in that industry itself. So, but it's definitely a really good baseline.
Exactly. A key element, as well as I mentioned before, is the calibration of the devices. That's usually should be calibrated for the exercise in this case. Sometimes some of our customers also require an end or exit calibration, just kind of to double check if there has been any kind of drift in that case. And here usually you should be kind of in accordance with the ISO 17025 when it comes to calibration certificates, etc.
Absolutely. Yeah. So just moving on a bit.
But yeah, and that was also what I mentioned before. Like how actually WHO fits all the other regulations that when it comes to actually temperature mapping, right? And here it is kind of what I noticed, because actually this was a fairly new topic for me to really dive a bit more into it. And it's kind of a red thread throughout all of those different guidelines and the relation to WHO. Almost all of them, they have some sort of compatibility in it. So if we go from the ICH and PICs, so those are the harmonized standards, right? Where kind of basically really much overlaps with the WHO Annex 9 in this case, and it's I think it's almost designed to be compatible with the ICH to some extent.
There definitely is a lot of harmonization been performed in order to harmonize, and I think that's also one of the key takeaways we should do today is that WHO guidelines are a good place to start, and you will do nothing wrong by following them.
No.
There are definitely more specific guidelines to follow, which are more extensive in terms of these, showing you how to do risk assessments or showing you how to document. We could recommend the ISPE temperature control chamber mapping and monitoring, which is a really good one. But there are several different ones out there. The PICS is also really good in terms of really going in depth with these different topics.
It's basically the WHO. It gives you a baseline, and then you add any other kind of guideline that is actually much more specific for your purpose in this case, right?
Absolutely.
That's how I understand that. And the same we have also with the USP. Also here they align very, very closely. And USP usually are used for the good storage and distribution practices. And also here, you can use basically the same principle to control your storage units, transportation conditions, and then finally maintain the product integrity. But also here, I read it through, and I don't know what is your view on that, but also here it's almost just kind of the guidelines of the USP here are just more detailed and a bit less.
Yeah, I think that the USP gives some general guidance on what should be performed and which precautions should be taken in order to ensure product integrity. I think if you sort of start stating from a list of complexity, you have the USP, the good practice, the GXP statements, and then moving on to the WHO guidelines, and then more details like PICS and also the ISP guidelines.
So basically vice versa what I just said.
I think it's just from different perspectives, right?
Okay. Yeah.
It's basically how deep down technical do you want to be? But I think that the key point is still that there's some really good technical and auditorial guidelines out there to follow.
Because maybe the USP is more kind of focus on the product integrity itself, right?
So in that sense that they have different focus.
Yeah.
I think in terms of time, I think we'll move on to where we really get into the material here.
Yes.
So talking about 5 steps, and we've chosen 5 steps that are relevant because we see a lot of customers failing in this or needing some information on how to perform these different things. Though this is not a full breakthrough of the WHO mapping guidelines, but we've tried to take out the 5 most important ones, and we'll kind of take some of our learnings because we perform hundreds of mappings here, and we really wanted to gather on some of that knowledge and give that forward. So the first step we've chosen here, and again, please don't be shy to ask some questions in the chat. It doesn't matter if it's related to what we're talking about right now. We'll try to catch up on it and take it either during or after. So the first one is requirements. This is really one of the places where we see a lot of our customers.
Uncertainty. Actually.
Uncertainty is a really good word. Yes, uncertainty about what the requirements specifically are. You touched base with it briefly before, but really understanding what are the requirements for the process that I'm in right now. And I've tried to make my own little model here. So this is not taken from any WHO guidelines, but basically the first bare minimum you should know is what are our high and low temperatures. This could be for fridge, ULT freezer, up to very large warehouses, even trucks and moving vehicles. What is the high and low critical value? That is a bare minimum for an auditor to want to see. We would also, if we're going to sort of the next level of this, is you need to have some sort of product knowledge. And why would you need that product knowledge? You would need it because there will be momentary excursions to the temperature. So in order to understand, well, if it goes outside my high and low limits, what happens? For how long time can we accept excursions outside those predefined limits? And in that case, both for how long and how much can we accept it? And is it different for different places in the cold chain?
And also for different products.
And for different products, exactly. And that's really one of the places where we see, okay, we see customers, most of them get by saying, okay, it needs to be between 2 and 8 degrees for cold storage, as an example. But I have yet to see a single cold storage that maintains 2 and 8 degrees perfectly, even with door openings, with new products entering the facility or leaving, or people entering and leaving the facility. So how much excursion can you accept, and for how long period of time? And the auditors would want to see this. They would want to see a risk assessment and see where did you get the information that it can withstand, 10 degrees above or 10 degrees below for a certain amount of time. And then lastly, the operational knowledge. So if you have had a facility for some years, or if you have experience running these facilities or fridges and equipment, whatever it might be, you would have some sort of idea of what are your requirements for how stable the temperature should be and how homogeneous it should be. And that's one of the things we're starting to see, that in terms of the basic principle, the quality principle of continuous improvement, you should start gathering some indicators of when is your facility performing well and when is it not, so that you have this as a baseline for defining how homogeneous this temperature should be and how stable it should be, also under different conditions. But at least the lower two ones should be a bare minimum, or the lowest one should be a bare minimum, but we do always advise on at least understanding momentary excursions in temperature. How much does that influence the performance?
I have a question. Like, can you just kind of describe a bit what do you mean exactly with homogeneity of the facility?
Yeah, it's a good question. It's a good thing you hear. So stability basically tells us something about how stable are the temperatures. That could be in a short term, so in a matter of hours, but it can also be during longer periods of time, so weeks or days or even weeks, and also due to seasonality. So basically, how well tuned is the control system that handles the temperature control, and homogeneity basically tells us something about how closely spaced these temperature points are. So
kind of the distribution
of temperatures, exactly, both in terms of like length and width in a warehouse, for example, but also in terms of height. Because that does tell us something about whether our insulation is performing as it should, whether air circulation is as it should. So these are some of the points that will make an auditor clap clap their hands and say, well done, but I don't think it's required.
And also, I do think kind of having a more in detail overview about the stability and homogeneity of any kind of units that you have, it allows you to some extent with more data to do also predictive maintenance on your facilities and on your units.
Yeah.
But that's something that's, it requires quite a lot of data there.
Yeah, absolutely. And I think I was just looking here because we have some interesting questions. Thank you very much. There was a question from Mustafa regarding whether software involved in temperature mapping needs to be validated and how is that validation demonstrated. And thank you very much, Connie, for answering exactly as it is. So mapping is a GxP activity, so any software would need to be validated. Spot on. So I think remember what the predicate rule is that if you need to do a GxP decision based on something, and it is a GxP required thing to perform mapping, then any software used in that sense needs to be validated. And thank you very much, Connie. You should be on our team here. GAMP5 is a great guideline. We're spot on. We use GAMP5 as a framework for validating all of our software. So we can only praise that.
So we're using for our continuous monitoring and for our mapping software. And
And there's another question here from Mohammed. Says, how is the operational knowledge helping to conduct a successful mapping study? Well, exactly as you says, it includes the historical data, the amount of deviations, alarms, all through that. So there's a lot of different things that can be included in terms of understanding the operation. Another thing is also understanding, have we increased our activities in a warehouse, as an example?
I mean, that means that we have perhaps more door openings. And what is the implication of that? Bigger warehouses, they do have also the forklifts coming in, right? And all that. So does this affect the environment, the warehouse in itself? That's in the warehouse kind of optic, right?
Absolutely. So another great question coming up here from Kana is what is the difference between the temperature mapping and humidity mapping? So there is...
But you map temperature and humidity.
Yeah, yeah, exactly. There you go. No, but really, temperature mapping is, I've never seen it not be required because temperature has a huge impact on product stability. There are some cases where you would require it due to your specific product and how it's stored and packaged, where you would need humidity mapping as well. which basically means because if you have cardboard packaging, you can have delabeling going on due to too high humidities. You might have a mold growing, and you also have in some certain API, if you have APIs that are susceptible to humidity levels, you would also have to do that. So sorry, Connie, to kind of a little bit disagree with you there. It's typically stable, and I totally do agree. But there are some specific cases where either due to governmental regulations, GXP regulations, or customer requests to do. Again, Connie, you're more welcome to join our next webinar, I think, Connie. So I absolutely agree.
You're spot on there.
It's normally humidity is normally stable throughout the volume, and you don't need the same amount of humidity data loggers as you do. If you go to very large facilities, you would need some more.
But usually, in my experience, when humidity was also required to be mapped, is quite a different ratio between the amount of temperature loggers that you need and the temperature and humidity, right?
Normally, as a rule of thumb, we normally say that we require 10% of the loggers to be temperature and humidity loggers in that case. But it's So I think we'll take some more questions later on. This really great questions. But moving on to the protocol, that's one of the other key points in terms of having a successful mapping. Yes. So the protocol, as we mentioned before, is one of the key parts of having a successful mapping. It states out a few things, and these are the most important things, I feel at least, to get in a mapping protocol. And that's actually regardless of whether you're following WHO or ISP guidelines. But the first one is the purpose and scope. And one might say the purpose, why it's important to show why. Well, it shows intent. It knows whether you're doing it because this is the first time you're using it as a GXP storage, or is it because you're revalidating it? And the purpose is to show alignment with some of the requirements. And the scope, this is really one of the key things that we often sometimes see lacking, is that we haven't defined what is part of this mapping exercise. So
a common issue can be that the scope is way too wide, right?
Exactly. So having a very narrow scope actually shows to the auditors that you've focused in on one thing regarding your mapping and how and when and what is part of your mapping exercise. So the second thing is requirements, and we'll take we just dug into that in terms of what those requirements are. But basically, again, have you ensured that you know how well defined your requirements are and why they are as such? The rationale behind choosing those requirements is really, really key.
And also here, I guess, but the requirements are, again, very much product driven.
Exactly. And I think also now that we are talking regarding the protocol, it's so important to be able to show auditors that you knew what your requirements were before you started doing the mapping exercises. We've seen a few cases with customers actually getting deviations because they did not know their requirements in advance of the mapping exercise. We're just getting some technical help here.
Thank you, Niels.
Thank you, Niels. We're running out of power here. No. And then thirdly, the methodology. So the methodology describes how are we actually going to perform this mapping exercise? What steps do we have to follow? And there's a myriad of different things, but it's basically where do you place data loggers, for how long time do you plan to conduct the mapping exercise, and how do you plan to retrieve that data afterwards. And then lastly, it's really, really important to have a good predefined assumption of how do you document all of this. How during the mapping exercise, how do you plan to document? What do you need to write down? And this is, I think, also something that the people performing the mapping exercise will be very happy for, because when you're standing there on a lift somewhere with data logs and the height, you often forget a lot of the Alcoa principles. That's a thing. But having really, really good expectations for how do you plan to document it. So
should we answer a couple of questions? Should we do it later? I think was
there's a really good question here. What are the basic things to include in the protocol?
And also we had one
Yeah, I'll just so yeah, exactly.
Okay.
As we mentioned, these are some of the most typical things to include in a protocol. One of the things we haven't mentioned here quite is you need to have a defined way that you will do the reporting. So you need to have defined this is the way we'll do reporting once we've conducted the mapping exercise. But WHO actually has a really good list of things that are required in a mapping report.
And actually, we do have on our website, you can download some free protocol templates.
Yes, absolutely.
Yeah. So feel free to check it out if you need kind of some, of course, it's a more general one, but it's kind of a good template, a good starting point.
So Mustafa, a great question here. Actually, what is the recommendation? Oh, sorry, just went away here. What is your recommendation for the sampling frequency of temperature? And does the duration of mapping correlate with the size of the space being mapped? So, first of all, with the sampling frequency, it's actually something that should be part of your mapping protocol. You should define how often do you expect to gather data. I would say unless we're talking processes that are sort of very high speed, like autoclaving or something, it really doesn't matter that much. I mean, something like 5-minute or 10-minute measurement interval should be plenty enough. There are cases where you'd want to do a door opening test, and you'd want it more. With today's technology and how fast data loggers can measure, I mean, I would always say to pick 5 minutes. That's plenty enough for all of it.
If you have some specific exercise, then you can always reduce this kind of logging time.
Yeah. And then there was a question again, Mustafa, does the duration of mapping correlate with the size of the space being mapped? Really good question, actually. It does to some extent. If we're talking like a large warehouse, there will indefinitely be, now we talked summer and winter mappings before, there will definitely be variations in terms of what we call external influences. So that's sunlight, the lack of sunlight, or very cold weather. So when your facility is very, very large, some of these dynamic influences will only show after longer periods of time. So as a rule of thumb, we would normally like to say do 2 weeks. If you're not under time pressure, it doesn't matter that much to do 2 weeks because you'll set up the loggers, they'll gather data, you'll go do something else, monitor it from remote, and then come back. So yes, it does influence it. With the smaller units like fridges and freezers, they will show those variations much quicker, and you can. Yeah, we would normally recommend doing that in days instead of weeks.
Exactly, but also just kind of the sheer size and the amount of work that you have to put in to compare to a smaller fridge, it's a different level of.
Absolutely.
It's much more complex. And Mickey, you're also there spot on. Like usually smaller units, they require a higher frequency of logging. Especially if you do door openings.
I mean, I think it's a more of a technical question. But I mean, again, today, if you can get 1 minute intervals for smaller units, just do it. There's the lower you go, the
better.
The better, yeah. So there was another question here regarding from Danielle. Could be a good idea to justify the choice of the test duration using historical meteorological data. Yes and no. So it's always good to justify when you performed the summer mapping and the winter mapping from historical meteorological data. But the duration, there's too much variance in historical meteorological data. I mean, I'm going on vacation next week. It's supposed to be warm outside, but I'm not sure. I can't, otherwise I think people would plan their vacation based on the historical data. But it really depends on when you place it more rather than for how long. You can, though, what we've seen a few times is to set up loggers, start the mapping exercise, and then wait for hot weather. So you use the historical data to say when is it likely to be in the area when it's hottest. Exactly. And then when you've had a few days of that, your mapping exercise is concluded.
As you mentioned before, it's about the critical period in time, right? It doesn't really necessarily, you can have some really mild summers and that will not kind of be actually reflecting on the actual performance of your warehouse in a very hot summer, for example.
Exactly. So I think we'll just move on slightly.
Yes.
in
We are a
respect
bit
to
behind
time.
the schedule, I think.
Yeah, some really great questions.
Yeah.
Thank you very much. So conducting the
Yeah,
mapping
mapping.
exercise, actually getting out there and getting your hands dirty. So one of the key points from this is, first of all, I would say planning. This is not part of the WHO guidelines, but when we're talking units that are in use, that are very large, or that are very likely to be interrupted by people, a really good plan is really key in terms of ensuring that you have the least amount of influence on your mapping exercise and thereby also your results. But also, we often see that there are a lot of stakeholders, especially if you're building new buildings, that will have an impact on, is the system actually ready to be mapped? That's one of the things we often see with new buildings. Does everyone agree that we're ready to start the OQ and PQ? Are we really ready to start measuring on this? Really one of the key points. Another thing is documentation is king, especially during such things as mapping exercises, because first of all, you should fulfill the requirements from your mapping protocol, right? You should document everything that's stated in there. But more than that, it's always good to write down stuff along the way that seems odd, or which will help you when you're writing the report justify why did we see these temperature excursions, or why did we see and so and so. I've seen dozens of cases where you get some temperature data back and it doesn't look right. There's some excursion or whatever, but because nothing had been documented rather than the bare minimum, there was no way to justify that this was because someone opened the door, or this was because someone accidentally turned it off, whatever it might be. So
what are the most common errors or kind of those anomalies that you see? What they are caused by?
Usually? Oh, that's a really good question. I mean, when we're talking new buildings, it's often that we see people adjusting the HVAC system because they were not aligned, that now we're testing, or equipment that's being turned off, or doors that have been opened. Sort of the normal work you would see with people entering and leaving. And then also we've seen a lot of cases where there's a lot of operational staff, which with very good intent moved the data logger because they needed to place something where it was standing, and they had no idea that it was very important that it was placed just specifically there. So there's a lot of these things. And the last thing is really, mistakes do happen. When we do a lot of mapping exercises with hundreds of loggers, and something will go wrong. I've never seen it go 100% right. Data loggers might be moved, as you just asked. Something breaks, calibration runs out because of damage, whatever it might be. But planning ahead will really take a lot of that headache away.
Exactly.
Stating how much data can we afford to lose because something has been moved or whatever it might be helps you just go on and write that report, rather than having to come up with justifications when you're actually at the end of the mapping exercise. And furthermore, having criteria for how much can we afford to go wrong before we need to redo the exercise is a really good thing, because whilst you're doing the exercise, you're under time pressure, almost always at least.
Yes.
And then having these criteria to define when can we go on safely, or when do we have to restart, because then we'll have to restart as soon as possible.
Yeah.
Right?
And here is also kind of where the real advantage of having real-time data comes into place, right? Because you are able to spot those mistakes basically almost immediately and act upon without kind of waiting the end of the exercise, download from your old USB stick, and then see that something was going wrong, right?
Absolutely.
It's a matter of being kind of fastly reactive to any kind of issues, and also matter of data integrity, because you're able to act immediately and replace, for example, a malfunctioning sensor or logger in this case.
Absolutely. And I think it's a really good point. Thank you, Miki. Like clear signage everywhere, people will open doors and impact your mapping. Yes, exactly. Yeah. That's a really good part of a good plan. Yeah. We're running a little bit behind schedule, so we'll move on here.
Yeah, on reporting.
Yeah.
We'll touch base quickly. I saw also that Chelsea, thank you on the chat that you shared our kind of templates there. So what is kind of the key elements of a reporting here? It's kind of course, that test protocol, right, which kind of emphasize and describes the importance of the mapping protocol here, and kind of it lays out, it's kind of this blueprint that I mentioned before, right? Kind of lays out your kind of what do you want to achieve, your goals, the steps that you have to undertake to perform the mapping itself, and how to follow those steps actually, which includes so many different things in this case, right? But so that's why important that the test protocol is written as detailed as possible in this case. And here we kind of, you want to focus in being kind of consistent and effective in your mapping exercise. Then of course is the huge work of data analysis, right? And here basically you have to kind of go through all your raw data, sort it, analyze it, spot kind of fluctuations that, as you mentioned, said, do not make sense, or why are there, or what's happening. And here you have to focus really kind of in understanding those data, to have kind of understand those kind of various fluctuations, those trends that you see across the facility or across your temperature control unit, right? And actually this is very crucial to decide where to place your temperature controlled products and which one where, if it's a warehouse, right? Of course, hot and cold spots, that's the baseline. So know your critical areas in this case. And of course, it's kind of also mistakes happened and perhaps the exercise doesn't go as you planned completely. And here, non-conformities are important. Because why they're important? Because quality is kind of, is also a mindset, right? And transparency. You say documentation is king, but that means also transparency. It's kind of the queen of a good quality process. So being able, transparent and being committed to address the deviations that or unacceptable temperature ranges, it's kind of is an important note that you should add, and then you can actually come with recommendations and be proactive in solving those problems and those issues, right? So all the recommendations should be kind of actions that are required to correct and address your non-conformities in this case. And also then you can also discuss kind of, what can be improvements that you can do, what kind of corrective actions will be taken, etc. And approval, that's, I mean, self-explanatory. That's you.
Absolutely, yeah.
So basically,
but
this
I think it's also important to state that the approval field is really also a place you could also, a reviewer, is really that, as you stated before, understanding that deep level of data that you can get. It's really, really important to have a reviewer on there, because you might get lost in the data. We sometimes see that you're starting to see ghosts, or you might overlook something that's not really important. Because also one of the key things is that a mapping is a point in time measurement.
Yes.
So any variations that we see, we must be able to justify, because that might just be a small variation we saw today, but when we remove the loggers, there'll be a large variation. So we also need to communicate in the report that we understand why the temperatures acted the way they did. Absolutely. So maybe I'll just follow up some of the questions. There's some great questions coming in here. There's a question from Mohammed: which statistical equation should be used for cold and hot spot analysis? Really good question. We've chosen a method now. There's not really any regulatory guidelines that precisely describe this. There's some minor recommendations, but anyhow, we'd normally like to say that we both state the peak temperatures. So what was the absolute highest measurement we saw and the lowest measurement we saw, and which position was that? Furthermore, we'd normally like to state that we have the highest mean and the lowest mean temperatures. In my mind, that doesn't give a full picture. So what we always do is that we include, or always depending on the case, include a box plot. So we basically say, where are 95% of the measurements for each position? and it's a very good tool to estimate. Well, we might see one spurious measurement, but consistently, where was the temperature and how much how was the stability of that temperature? So a qualified guess based on those graphs, in my mind, is better than just picking out the single highest and single lowest point. It doesn't add value to understand what temperatures are.
What a box plot exactly represents?
I mean, a box plot really represents where do you have your median or mean of temperatures, depending on what you choose. So the average, or sort of the average, and then where do 50% of all your measurements lie, and where do 95% of all your measurements lie, and really gives the best picture of what are the typical temperatures
in this.
What are the typical temperatures to expect in each position. Let me just, there was another really good question. Box plots, yes. There was a question regarding to map loaded or empty, and again, there's a lot of great answers in the chat already. It's great that you're helping each other. So at least the ISPE guidelines clearly state that mapping should be performed empty and full. And why is that? If you have a warehouse or a fridge, or it doesn't matter actually what kind of, if at all times it's fully loaded, well, then you can map fully loaded and only do that, because that will be the only scenario. But the rationale behind doing empty and full is that if you have somewhere between 100 and 0% loaded, that will be the scenario. And the underlying rationale is that if we map it fully empty and fully loaded, we will have an idea also of what the temperature distributions are within those two limits. That's the underlying distributions. I believe it's the ISPE or some other guideline, can't remember clearly, that states that you should map at 0, 50, and 100% as well. We've never seen that. We've never had any deviations, only doing empty and full. And then as someone else noted in here, doing just fully for the revalidations, I think that's a valid approach. It's not exactly what the guidelines say, but again, we've never heard about anyone having gotten deviations for doing just a fully loaded doing revalidations. Great questions.
But it's also because, again, I have always fall into the HVAC system because it's kind of where I've been working the most, right? A fully loaded warehouse, it might, deviate the airstreams that your HVAC system is blowing and create different hot and cold spots in this case. And I do see probably kind of, for warehouses that has a high volume and kind of, it has always kind of different fluctuations into the goods that are stored, to do a 0, 50, and 100% full loaded kind of test in this case.
Yeah, absolutely. Yeah, so
I think we are just at the end with the last slide.
So last step, implementing recommendations.
Yes, so basically it's just a run through what we've been talking, those 5 main points, right? Kind of is, of course, implementing kind of first of all, it's conduct a comprehensive review of the WHO standards. That's 101, so that you actually able to understand the guidelines. First of all, that's kind of the most important thing, is kind of the understanding, and then you can perform eventually, perform a gap analysis and identify kind of discrepancies of your current practices here in the WHO standards, but also engage kind of, as you said before, the planning and all that. So that involves a whole lot of other teams that must be kind of brought into this single exercise, right? And here comes also the staff training that you have to do to execute. Like, you need to have people that understands, know what are the goals of the exercise, and they actually work for a successful outcome here. Then we do have scheduling of your validation processes.
I think that's a very key part. We often also see that people tend to forget to set up criteria for when do we need to revisit this and revalidate. That's really one of the things auditors will be looking for, right? You've conducted your mapping exercise. It was great. The documentation is good. But when or what, under what circumstances do you need to do this again?
Exactly, right? Exactly. And then, of course, after you've done your temperature mapping exercise, what you have to do? Install your monitoring system. And also there you can actually very much, I think, optimize your continuous monitoring with kind of having a full exercise that really mapped out what are your critical areas in your storage unit in this case. And conducting a mapping exercise on a long term is also cost efficient exactly because of that, because then perhaps you are really able to reduce at kind of to the bare minimum your data logger fleet or your measuring points for your continuous monitoring, because you've done a mapping study and you conduct a mapping study regularly, right?
Absolutely.
And last but not least, documentation of changes here.
Yeah. I think it's one of those places where really, when you get to that point in which you plan to revalidate, or you should review whether to revalidate, documenting the changes on your facility or equipment is so much key, and you'll regret it the day you're there not having documented all the changes that you performed. So that's really one of the key points. Right?
Exactly.
Yeah, and I think we're at the end here. So we really hope you've enjoyed this. We're all out of time right now. So, but thank you for the great questions.
Yes.
And don't hesitate to reach out to either Alex and I, or get into our website, and we might be able to help you in the future.
Exactly.
But we're always happy to connect on LinkedIn or write or phone us, and we'll be happy to answer some of your questions afterward as well. So thank you very much. And
it was a pleasure.
It was a pleasure. Have a lovely day, everyone.
Yes.
Bye.